Well, ladies and gentlemen, thank you for joining us again. We're halfway through the OpenSIP Summit 2020 distributed. Last 2 days have brought us some amazing topics. We had some great talks about uh, the status of what's going on in the OpenSIPs VoIP world. I'm not the OpenSIPs, but the open source VoIP world. Both core developers from OpenSIPs, Liviu and Vlad, gave us some great look at some of the new stuff that's in there. Today, we're going to be going to Mr. Maksym Sobolyev. He is the head guy over there at Sippy Labs, and he's going to be talking to us about RTPProxy, OpenSIPIt, and MicroSippy. And just as we are mentioning Maksym, I want to thank him again for doing an amazing job getting this all broadcasted and connected to all of you. So without much further ado, Maksym, take us away.
So hello everyone. My name is, has been said, is Maksym Sobolyev. I'm first I'll give a little bit since I know there are a lot of people in this room who probably have not met me at the OpenSIPS Summit. I'll give you a little bit of introduction who I am. So born and raised in Dnipropetrovsk, back then USSR. About 15 years ago, I moved to Vancouver, British Columbia, Canada. I have a master's degree in physics and radio physics from Kyiv State University. And I was always, since I was a kid, I was always between kind of computers and science. So it's basically to the interest that that I still pursuing in some form. I got involved into open source movement in my late years in the university. I discovered FreeBSD, and I was just curious about Unixes and operating systems in general. So I got involved as a user first, and then started submitting patches, fixes, and so on. So eventually joined the project, and I'm still one of the developers to date. I think FreeBSD, it's not very well publicized, but it's one of the biggest open source projects, organized open source projects right now. So there's like 400 active developers working on the code, and yeah, so that's kind of some background on myself. Then why I'm here exactly? It started with in 2003 when I got a new job. First my job in computer and telecommunication industry after finishing school. And we've been trying to implement some SIP switching functionality into existing billion platform. So as part of the job, I was started investigating. SIP was just fresh out of IEFT. I think it's they approved in 2002 into RFC. So basically, at that point of time, there was not only like probably 2 or 3 projects who implemented SIP in one form or another. So as I said, I was pretty excited about open source and its uses in the industry. So we started looking at open source implementation. I got discovered SIP Express router, which was at some early versions, but still the kind of the core of functionality was there. So, and as I said, since it was in early stages, there are a lot of functionality which we take for granted these days was either missing or in very early stages of development. So one of the obvious things was absence of any NAT traversal support, which was kind of one of the biggest issues of on the list because it's not really covered by RFC. So we basically started looking at what could we do to make SIP work good with the NAT and all that. It basically ended up with creating our own module, which we called NAT helper, and contributed it shortly to the SIP Express router. And then we also discovered that in some scenarios we could not handle not 100% of the time without some kind of support on the RTP side. So we basically prototyped RTPProxy and again contributed as open source. And at some point of time, it was even part of SIP Express router CVS repository.
Maksym, do you remember the story after the RTP proxy, was made public? I think in terms of months or maybe 1 year after that, there was the the whole story with the media proxy released by the AG project, and I remember it was a kind of a funny situation because Adrian just announced it and he keep saying, okay, the media proxy is better, and everybody was asking why. I mean, what's different? And it was like, no, it's just better. And it was this kind of a stupid, back and forth. Like, okay, he was saying it's better. Everybody was asking why. And after some time, I think I'm not sure who discovered or it was admitted that the only difference actually was, okay, I think they were doing also relaying for the RTCP packages, not only RTP or something like that. No, but they were keep hiding and they're just saying, okay, this is better. And I remember that was a kind of a small, firestorm on the mailing list at that point. Like, what? Really? Tell us, what's the difference? But yeah, I still remember that.
Yeah, it was a little bit of that. And also, I think we got a little bit of squabble, I would say it, with Adrian about the fact that they used a lot of code from RTPProxy module in SOR to implement media proxy module, but they did not put copyright notice, and I got a little bit upset by that. not so much about what the difference is. But anyway,
what you're saying is that squabble was a gentle euphemism.
yeah, well, I met Adrian a few times since then, and I think we're both kind of pretty relaxed about it. So now it's more like a fun story to tell, right?
Yeah, no, exactly. I mentioned it more like, I mean, it happened like, 15 years ago, but, yeah, looking back just to see the whole story behind, all the struggles with all the open source code and different kind of approaches, versions, and so on and so on and so on. Yeah, sometimes it's, not funny, but I would say, yeah, it's interesting.
Enough stirring the pot. Let the man get back to his presentation.
Yeah, so thank you, Bogdan. Actually, it was pretty fun to remember that. But anyway, we kind of our own approach to the open source is basically whenever we're practical people, so we try to implement practical things here using open source software. And whenever we find something that is could be improved or in a good way change that software, we try to contribute it back. So essentially that kind of continues in 2009. I think we were first. We started working on this module actually earlier. I think it was in 2007, 2008. Since we also implemented Python B2BA, we found it's very very compelling that we could use some of the Python code from our SIP Express router configuration script. And so that's kind of ended up with us creating a Python, which we then contributed back to OpenSIPS first and Camellia a year later. And it's been I don't know, we did not have much presentations about it in OpenSIPS side, but I heard a lot of people using it on Camellia side of things. So it was definitely good idea as well, even though it's not very kind of, we don't bang it too much. But anyway, it's streamlining to today's more closer to today's date. We've been also pretty since we discovered our first OpenSIPS meeting, I think in 2015 or 2016. Oops, sorry, some echo. We went for it was in Texas, one of the since the only US event to date, unfortunately, but we'll hope it changes someday. We kind of loved it, and we discovered there is a lot of good people and very active community. So we found we met Alex, obviously, and it's been amazing since then. But we also met a lot of other people in the coming years. So yeah, it was very interesting, and we tried to participate it and help to build this community even bigger, doing online streams from about 2017 from Amsterdam. And yeah, we're still trying to be involved in ongoing work with especially questions related to RTPProxy or not helper. So, and if we find something not working, we will try to report it, and at least if nothing else. Sometimes it might be just easier to fix it and submit a patch. So anyway, that's kind of a little bit of story of our involvement with OpenSIPS and its community. On the other end, in those years, what else we have done? I organized, after working for a few years for different companies in this field, I organized my own SIP software business in 2016. I don't know, keeps me busy ever since. We're growing steadily, but at least it goes up, so I'm pretty happy about that. We also do a little bit of, since 2015, we also do a lot of work in the background by building some CI integration tests, which helps us to track any deficiencies or any new issues introduced in latest OpenSIPS versions or Camellia or B2BA. I can probably just give a brief overview. Let's see if I can switch my screen. You guys see, right? Presentation. So this is our VoIP test projects. Zoom in.
Just a little.
Yeah, and basically here we have a set of about 30 scenarios, which we then run through different combinations of Camellia, OpenSIPS, Sippy B2BA, and try to see if there are any problems with the call flow. It works pretty well. As I said, we've been, oh, sorry, I did not switch my tab. So basically there are some nice diagram here. What it does, and and basically we put those different versions and test them against different versions of RTPProxy, making sure that nothing gets horribly broken. And whenever something comes up, we try to report. And it turns out this this kind of setup is very helpful in actually tracking those problems more deeply. So here you see, for example, instead of doing like different versions of different product, we just stack up different revisions of OpenSIPS code, and it basically pinpoints us when the regression was made. So we only test every day for the main branch, but whenever a problem comes up, we can basically easily, or relatively easily, with the help of Travis, to narrow down to specific commit which broke things. But anyway, that's side note. Let me just switch back to my presentation. All right. So that now more to the point of this presentation, or to the main topics of this presentation. First, I have several, at least 3 topics to cover. So we'll probably give people a little time to ask questions after each section. So in order to get started with the first section, I'll play 2 short video clips and ask people to at least think what the difference, important difference might be between those 2 systems, or post it on the chat would be interesting too, and I'll give you my answer after that. So this is the first clip.
Good evening, Dave.
How you doing, Hal?
Everything's running smoothly, and you?
Oh, not too bad.
Have you been doing some more work?
A few sketches.
May I see them?
Sure.
That's a very nice rendering, Dave. I think you've improved a great deal. Can you hold it a bit closer?
Anyway, and the second clip is this.
Hey Google, what is OpenSIPS?
According to Wikipedia, Camelio, formerly OpenSIPit, is a SIP server licensed.
Anyway, so obviously the answer is stupid, but apart from that, what do you think is the difference, and how we can possibly make it better? I'll give probably viewers 15 seconds to think. All right, now my answer to this is, well, it is Space Odyssey 2001, so it was before SIP 2.0, but probably it's feasible to think that SIP was already, SIP 1.1, which is RFC 2533, was already around. So if I were to implement this real-time communication system, I would probably use SIP, and then you can basically, as soon as you can view it as having like whole 9000 backend somewhere in the trunk of that spaceship, and there are a lot of UAs all around, those cameras, speakers, and so on. And so it's pretty feasible to have real-time communication between Dave and Hal in that scenario. Whereas if we look at the what been implemented these days, it's all HTTP based. So basically we have this Google UA, which is Google Home in my case, which collects recording and then posts it to the whatever Google AI backend, how you call it, waited to process it and send back a response, which then played back. So it's all very non-real time and very clunky in my view. So that's kind of background for why we wanted to do like small, very small implementation of SIP, which we call Microsippy. And it also, if you look into this a little bit deeper, again, I don't know how many viewers are familiar with how this integration with the AIs is done these days, but usually you get your where is the pointer? There is pointer. You get your speech, you then do some framing, and you basically convert it into frequency domain, and then you feed it into the recursive neural network for further processing. And if we've put like SIP into this picture, you see there is pretty much the same thing going on with the codecs. In order to send audio over network, you usually apply some kind of codec which essentially does the same thing. It basically takes your speech and which is time domain signal and converts it into frequency domain, which we call G729 or whatever codec you might like. So essentially, apart from the real-time scene, it might also allow doing something like this, where you can basically encode your stream on the client and send it over network, and then feed directly to your AI without decoding first. But anyway, the whole point of this MicroSIPy project is to create small SIP implementation, and by small I mean really small as it can run on anything pretty much which has at least some processing power. We use a lot of experience building our B2B UA, and obviously working with OpenSIPS gave us or NCR for a long time gave us a lot of knowledge on how to create we hope good SIP stacks. So basically this project is very quite early stages of development, but we got some promising results. So we have from what we see very quick SIP parser and tokenizer. I'll show you some numbers maybe, but we also managed to put the whole parse structure into one buffer with the SIP message itself. So essentially, you have only one allocation for the whole parsing stage, and it's very easy to basically get rid of it. Because if you look at the existing codecs, sorry, not codecs, SIP implementation, even small ones, it's basically done with kind of bunch of mallocs. So you have one structure which has a lot of smaller structures, and managing it would takes a lot of time on smaller system, because even something small as calling function takes significant chunk of time in real time terms. Anyway, some of the results we got, we about 2 millisecond SIP parse time at a very small microcontroller like this. I don't know if you guys can see it, but it's this ESP8266. It's not the latest. The newest has 2 cores, but this is just 1 core. And the idea is that you probably want to be able to do like SIP interaction quick enough so you can handle your RTP stream, which is 100 packets per second. So you have 10 milliseconds between packets to do other stuff. Well, not 10 because some of the time will obviously be spent on actual RTP processing. And also this code, we try to organize it in more or less platform independent way. We have 2 separate backends at this time. So we basically have this microcontroller backend, which is based on FreeRTOS, and also build POSIX into it, so we can have automatic runs on the Travis, and basically make sure we are not we remain compatible with even latest CPUs. Okay, I think I need to speed up a little bit. So yeah, there might be some other possible uses for this code. You can potentially look at it as kind of SIP accelerator for higher level language implementations. So we are definitely considering using this code at some point to make our Python SIP implementation more scalable. There might be some interest from the perspective of deep packet inspection on a desktop server class CPU. We can reach with single core. We can reach already 150,000 SIP packets per second parsing rate, and yeah. Might be some other uses. For example, as I mentioned, we pack everything parse structure and the SIP message itself very tightly, so it might be interesting to see if there could be potential uses for transaction serialization, because you can basically parse your message once and then distribute it between several entities and avoid parsing it again on each of them. But anyway, so the status of it, we were hoping to get something that can actually pass RTP this year, but we're still in progress. However, SIP parsing and tokenizer are good enough. It basically, I can just give a quick overview look at stop. So this is actually what is running on this microcontroller you have, and it basically set up this way. So each time the vendor of the board pushes the new version of FreeRTOS, it will build and run it here. But as you can see here, we parse pretty detailed. We do pretty detailed parsing, so it should be good enough for building higher level abstractions on top of it. The next step would be for us is to implement some of the transaction logic support. And again, if you guys get interested to do something cool, let us know definitely. For now, it's just me working on this code, and yeah, I have a lot of other stuff. So, and there are some other potential implementation which we see maybe a little bit later down the line. Some of them were, if you want to find more information, there was presentation 2 years ago in Amsterdam, which is available on OpenSIPS channel, which you can watch if you have not seen it already. Okay, so that's Microsippy part, and yeah, if you guys have any questions, shout out on the chat. Try to answer it. In the meantime, I will move to the RTPProxy. As I mentioned before, it's the project been around for a long time. Unfortunately, one thing that we did not really manage to do over the years is to build some kind of community around it for some reason. Well, we got help from people, but it's probably some of our fault. So the things are not progressing as fast as we wanted to, but it's mainly because we have all other stuff to do. But nevertheless, since the last OpenSIPS summit in April or May last year, we did some work on that. And first, I would like to mention is the test coverage. We're basically pushing 91.5%, and that's across all the code. And it took us about 2 years to get to this point where we could basically exercise pretty much all the lines that matter in the code to build the test cases and all that. But that looks good. Then another thing that we are actively working on is plugin module interface. There will be some information from it, I think, on Razvan's talk later about some of the first modules that we had. But in general, we were trying to build some kind of generic interface for people to plug in their functionality, which would do some interesting stuff with RTP into separate modules, so we don't blow it up and and make the core of RTPProxy slower and more complicated. We also adapted the configuration parser, which is now used mainly for the configuration of those external modules. And we definitely would like to make it more all-encompassing to also allow parameters which are right now specified on the command line to be in the config file as well. But then for that module interface, we did quite interesting work, which Razvan is going to talk about last November. I think we implemented the ability for RTPProxy to capture DTMF and report it back to OpenSIPS. And I should give shout out to OpenSIPS guys, and it was very smooth and very kind of very good collaboration. And yeah, basically we also have full test case for these scenarios as well. So we basically have it all covered into the test scenarios. And then the HAP integration, we had it for a little longer than DTMF. I think it was added about year and a half ago, perhaps, which would also be included in 2.2 as a module. And apparently some people already using it. We got some bug reports when we broke it during development. So that's I think a lot of people might look into that. And then since the last summit, I got some help from from some community members which I met on OpenSIP Summit with building up a little bit of online documentation for the RTPProxy, covering some of the scenarios, deployment, system deintegration, and so on. And the last big item, I think, is the implementation of the link time optimization, which I done about 2 to 3 months ago, which I think all pushed into the RTPProxy master and will be available in in the next release shortly. And for those who don't know, link time optimization is basically more high-level optimization mechanism where you can optimize compiled code, because in the original Unix approach, you compile your code into object file, and that's already like unit in itself. You cannot optimize it further. But with the link time optimization, your code, your source code, C code, is compiled into intermediate optimization, saved into object file, and only at the linking stage, the compiler or linker in this sense, but it's pretty much the same, will do optimization by pulling functions from different modules and combining them for better performance. So I think that's all updates I have on RTPProxy and of things. I think we have a question from Stas Kabzar. He asks, I joined a little earlier. If you ask something you were saying already, but did you consider using lexers like RE2C or Ragil state machine for parsing SIP? That's a very good question. Thanks, Stas. Well, I have not really looked into those particular approaches for parsing SIP code in general, and maybe that's something I should do. However, I looked into like bare SIP and those smaller implementation, PG SIP and so on, and those seems they suffer a little bit of that syndrome where you kind of expect, for example, things like STR to work well, but on the smaller system, even like things like finding the end of the string is not trivial if you look at it, because if you just do str for those 2 characters, it will kill your performance right away, because essentially 2 milliseconds that I mentioned before, it's about the times that you have average function. You can call average function for like str or something only like 30 or 40 times. So if you need like 20 calls to just to identify the ends of the string, that would pretty much end of game for this. But with a little bit clever of bit magic, you can basically do very, very interesting stuff. But yeah, I don't think we have time to go too deeply into this. But in any case, if you have any particular suggestions or experiences, please follow up. So I guess that's all for the questions on this one, and I'll move to OpenSIPIt thing. So what is OpenSIPIt and what we want to achieve with it? For those who've been around for at least I would say 7 years or 10 years, you might still remember this event. It was called SIPIT, and they did a pretty good job in the early days of SIP by bringing several independent implementation together from the industry and having them to run tests of various SIP scenarios between those implementations, and then identify any issues or any problems or anything pretty much, and hopefully get it fixed sooner. They even at some point gave some feedback to the RFCs, groups working on new RFCs, as to what needs to be improved or fixed. But regardless of that, that was a good job. But there are a few things that we kind of did not like as much. The fact that it was pretty difficult to get into without like big pockets and stuff like that. So for the first 10 years of our existence, we only kind of looked at it and was hoping that someday we could actually participate, which the DKM actually have as a badge of honor. It was SIPIT 32. I think it was unfortunately the last one they did. It was held in University of New Hampshire, and they have very big and very well equipped interoperability laboratory. Although we did not use obviously much of it, we just used internet, but they gave us a little tour, and it's apparently very big in the industry. All those anything like any electrical things or anything that gets produced in any considerable amount gets extensively tested. But anyway, go back to OpenSIPIt. Since we really like that idea, and we really hoped we would follow up with it, but for the reasons that are beyond our control, they just stopped after number 32. And over the years, I spoke to some of the people who organized it, and we did not get much traction in getting it restored or resumed. So as our approach, if we cannot get Vault to do something that we want, we do it ourselves. And that's kind of the idea about OpenSIPIt. Differently, we want to do it a little bit, spin it a little bit differently compared to original SIPIt. We want to be it fully open source, or at least as fully as we can, fully open source based events. So we at least expect that all people who participate use open source implementations, which would allow us to hopefully fix and resolve bugs right on the spot or very shortly. It would also hopefully let us build some of the tools and share configuration with the broader community, because as the last step of this event, we hope teams will push the configuration to the public repository, so all people can look at it. And as I said, we want it to be as open and accessible as possible. So we're basically, you don't need to have like big corporation backing your implementation or your SIP whatever to participate. And last but not least, we hope to get everything streamed on YouTube in real time. So we at least hope will be fun, not only to participate, but also to watch. Again, we're running out of time, so I'll just skip all those slides and faster pace. So we hope at least at some point to test extensively some of those rarely used scenarios, and maybe also put implementations into little bit harsh environment, like simulate packet loss and high latency, put some memory shortage constraints and so on. Because in my experience working on RTPProxy tests, there are a lot of bugs hiding in those never exercised or rarely exercised code paths, because you call malloc and you assume you get something. Even if you have a check in the code and it looks okay, it might not work very well in practice. So the idea basically is to run everything on AWS EC2 cloud. There is no particular reason to pick this cloud apart from the fact that it's probably the longest cloud in existence, so it's the most advanced in our view, and people, at least majority of the people had participating in the event will have some experience with it. So each team will get its own instance, and will set up network between those instances and run our tests. At some point, again, I'm not sure if it will be done for this first version. We would like to have some kind of advanced nighting scenarios as well, but at the very least, it will be network between the participants. So yeah, for this event, we already agreed with lot of, considerably good amount of projects which represent quite big share of SIP protocol users in open source world. So thank you, OpenSIPS first. They've been amazing with the support and all that, and hopefully we'll have them participate actively next week. FreeSwitch, our own team. Then we will have Dractio, Camelio, and also interesting thing that we got interest from SIP Vicious, which is enable security guys, Sandro and his colleague Alfred, I think, who will also be participating, and hopefully will shoot us with some nasty traffic and see how it goes. Anyway, we only have 2 minutes left, so basically the focus for this event will be SIP push notification tests, the amazing work that Livio done in OpenSIPS recently. We also want to have at least some amount of testing for the new SIP digest authentication RFC updates, which is 8760, which finally puts some non-obsolete digest into SIP authentication schemes, and the thing that everybody loves and hates, stir shaken, which we still don't have much of the understanding about what can we test. But anyway, it will be very dynamic, and we'll figure something out. I mean, with all those people in the room, I mean, it just could not go bad. So yeah, that's about it for my update. I hope I did not bore you guys or put you to sleep, because we have a few more pretty amazing presentation today, and there are some contacts. I'm available on the chats. Yeah, if any questions, let me know. And thank you.
I have a question about MicroSIPy.
Sure.
Maksym, have you tried the MicroSIPy on many platforms like ARM-based? How are you testing that right now? You are playing with Raspberry Pis with?
No. As I said, I have this microcontroller on my. I don't know if you can see it.
Which
is like this.
Okay, so it's an ARM-based one?
No. It's not an ARM. It's its own processor. It's called ESP8266, I think. And it's basically sort of hybrid between microcontroller and real processor, so to speak. So it's smaller than the ARM, but a little bit bigger than like Atmel and all those low level chips. But it runs RTOS. So what I do, I basically hook it up to Jenkins, and there's a lot of unrelated builds. But it basically it runs on the virtual. The Linux runs on my virtual machine here, and this board plugs into that virtual machine, and that virtual machine builds the code, uploads it, and then shoots some SIP messages back and forth between the host and this little guy here.
So you're kind of like of porting some of the open source projects you have built until now. So what are you running right now on the RTOS?
Oh, it's just RTOS. The way RTOS works, Vasilias, is basically you build your application. It's like monolithic application. You don't really run applications. So you basically you take your RTOS, you put your code in it, and you build into one binary, and then you push it to your microcontroller.
I had an experience with an AVR32 Atmel-based 10 years ago, so I really understand the core the core of that. So the project is great, and I think it has potential in the IoT industry. It can run anywhere. And
yeah, well, that's the idea. Yeah, that's the idea. Because if you look at the fridge or your car or anything, it does a lot of things. I mean, it won't be able to, put everything for SIP, like all resources. So your SIP should be as small as unintrusive to the whole application as possible, and that's something that I want to achieve with this MicroSippy project.
Okay.
Awesome. Do we have any other questions out there? Light them up.
All right, I think we're good. I mean, as I said, if you guys have any questions.
I have a question.
Sure.
When is RTPProxy 2.2 going to be released?
Well, I wanted to do it yesterday, but then I went on to slides. So I'll try to push it today, at least the branch. Yeah, it's always like this. I mean, I still have some tests that I wanted to fix, but yeah, I'll try to push it 2.2. Yeah, later today.
Take it easy, Max. No pressure. No pressure.
No, put pressure on me. Otherwise, nothing is done.
But I heard that there is some plugin architecture, and some plugin is almost ready, and maybe someone will speak about in the next presentation.
It's possible. It's possible. Well, it doesn't
right.
look like we have any further questions. Hey, Max, thank you so much. That was awesome.
Thank you, Max.
Maksym Sobolyev, everyone.
Thank you, guys. Thank you, guys.